Types of radiation, the discovery of the nucleus, half-life, and uses of radiation. There are three main types of ionizing radiation emitted from the unstable nuclei of radioactive atoms. These are alpha, beta, and gamma radiation. Alpha radiation consists of alpha particles that are made up of 2 protons and 2 neutrons. Because protons are positively charged, alpha radiation has a positive charge. Beta radiation consists of high-energy electrons emitted from the nucleus. These electrons have not come from the electron shell or the energy levels around the nucleus. Instead, they form when a neutron splits into a proton and an electron. The electron then shoots out from the nucleus at high speed, leaving behind a new proton. Gamma radiation is a very short wavelength at the high end of the electromagnetic spectrum. It is similar to other types of electromagnetic radiation such as light, X-rays, and visible light. Radiation can be absorbed by substances in its path. For example, alpha radiation only travels a few centimeters in air, beta radiation travels 10 centimeters in air, and gamma radiation can travel a very long distance in air. Beta radiation needs thin aluminium to stop it, and gamma radiation can only be stopped by very thick lead, as this will be needed to absorb it. Alpha particles are positively charged, beta particles are negatively charged, and gamma radiation is electrically neutral as it is a wavelength. This means that alpha and beta radiation can be deflected by magnetic fields, but gamma cannot. Remember that opposite charges attract. Beta particles are negatively charged, so they will be attracted towards the positively charged plate. And a positively charged alpha particle will be attracted to the negatively charged plate. Because they consist of charged particles, alpha and beta radiation can also be deflected by magnetic fields. Just as with an electrical field, gamma radiation is not deflected. In a magnetic or an electrical field, beta radiation is highly deflected because it is small in size. Alpha radiation, even though it has a charge of +2, is only slightly deflected, as when it's moving through, it will get stopped by the air particles in its way. The two main types of radioactive decay that you may be asked to look at in an exam are alpha decay and beta decay. In alpha decay, 2 protons and 2 neutrons are lost from the nucleus when it emits an alpha particle. This means that the atomic mass of an atom decreases by 4 and the atomic number decreases by 2. A new element is formed that is 2 places to the left in the periodic table than the original element. For example, radon decays into polonium when it emits an alpha particle. In beta decay, a neutron changes into a proton plus an electron. The proton stays in the nucleus and the electron leaves the atom as a high-energy electron. The nucleus has one more proton but one less neutron when it emits a beta particle. This means that the atomic number stays the same, however, or shall I say the atomic mass stays the same, however the atomic number increases by 1. We now describe an atom using the atomic model. The atomic model shows that we have a positively charged nucleus surrounded by negatively charged electrons. Atoms contain three subatomic particles called protons, neutrons, and electrons. The protons and neutrons are found in the nucleus at the center of an atom. The nucleus is very much smaller than the atom as a whole. The electrons are arranged in energy levels around the nucleus. So protons have a positive charge, neutrons have no charge, and electrons have a negative charge. The number of electrons is always the same as the number of protons, so atoms are electrically neutral overall. Atoms can lose or gain electrons. When they do, they form charged particles called ions. If an atom loses more electrons, it becomes positively charged. If an atom gains electrons, it becomes negatively charged. You should be able to describe the main stages in the development of the theory of the atomic structure. John Dalton developed an atomic theory in the 1800s. He did experiments that worked out some atomic weights and invented symbols for atoms and molecules. His most important conclusion summarized that all matter was made of atoms. Atoms cannot be broken down into anything simpler. All atoms of a particular element are identical. Atoms are rearranged in a chemical reaction, and compounds are formed when two or more different kinds of atoms join together. Right, Thomson discovered the electron in 1897. This showed that the atom contained smaller pieces, whereas Dalton thought that the atom could not be broken down into anything smaller. Rutherford in 1911 used experimental evidence to show that an atom must contain a central nucleus. This was further evidence that an atom contained smaller pieces. Rutherford designed an experiment to test the Plum pudding model. The Plum pudding model stated that an atom was made up of positive and negative bits randomly scattered around in a spherical manner. It was carried out with the assistance of Geiger and Marston. A beam of alpha particles was aimed at a very thin gold foil, and their passage through the foil was detected. The scientists expected that the alpha particles would pass straight through the foil, but sometimes various other things happened. So, as the alpha particles passed through it, bearing in mind that this was done in a vacuum, so the air did not stop the alpha particles, most of it went straight through. This shows that most of what makes up an atom must be empty space. Some of the alpha particles were slightly deflected. This shows that some of the positively charged alpha particles must have been pulled towards the negative electrons that were orbiting the atom, and very few particles were bounced back. This shows that in the middle of an atom there must be a dense core capable of bouncing back alpha particles when they hit it. The nuclei of radioactive atoms are unstable. They break down and change into completely different atoms. This is called radioactive decay. For example, carbon-14 decays into nitrogen-14 when it emits beta radiation. As this breakdown occurs, the activity of a radioactive source becomes less. This can be measured. It is not possible to predict when an individual atom might decay, as this is a random event. But it is possible to measure how long it takes for half the nuclei of a piece of radioactive material to decay. This is called its half-life. There are two definitions of half-life. They are that the time it takes for the number of nuclei of the atomic isotope or radioactive isotope to halve, or the time it takes for the count rate of a sample containing the isotope to fall to half of its original level. So in this example, we start off with a count of 80. It takes it 2 days to go down to 40, so therefore one half-life is 2 days. It then takes a further 2 days for it reduce to 20, and then a further 2 days for it to reduce to 10. There are a wide range of uses of radiation in medicine and in industry. Although ionizing radiation can cause cancer, high doses can be directed at cancerous cells to kill them. This is called radiotherapy. About 40% of people with cancer undergo radiotherapy as part of their treatment. Doctors may also use radioactive chemicals called tracers for medical imaging. Certain chemicals concentrate in different damaged or diseased parts of the body, and the radiation concentrates with it. Radiation detectors can be placed outside the body to detect where the radiation is emitted. When a radioactive chemical is used in this way, it is not normally harmful because the radioactive isotope that we use does not have a long half-life. We can use radiation to monitor the thickness of materials in industry. Radiation is used in industry in detectors or by detectors that monitor and control the thickness of materials such as plastic, paper and aluminium. The thicker the material, the more radiation is absorbed, the less radiation reaches the detector. It then sends signals to the equipment that adjusts the rollers, which can change the thickness of the paper. The type of radiation needed for this use has to be beta, as alpha radiation would be completely stopped by everything, and gamma radiation wouldn't be affected by the thickness of the material that you're trying to change. So remember, start your revision early. Quality revision is better than quantity revision. Keep making flashcards and asking yourself questions, and turn off all distractions when revising. Thank you and good luck with your physics exam.